Video, we're going to be discussing solving linear quadratic systems algebraically. So as we discussed in a previous video, the solution to a linear quadratic system is the point where the two equations are equal to each other. Okay, in a previous video, we talked about how to do this graphically, where if we had a quadratic and a linear, that we were looking for the points where those two equations intersect. What we're going to be doing today is the same thing. We're just going to be doing it algebraically without a graph. So what we can do is we can solve this system by setting our equations equal to each other and then solving the resulting equation. And that resulting equation will always be a quadratic equation. So our procedure here is fairly straightforward. The first thing we want to do is we want to isolate y in both equations. We want to get it so it's y equals something. Then once both sides are equal to y, because they're both equal to y, we can use substitution and we can set them equal to each other. That'll give us a quadratic equation. We're going to solve that resulting equation for x. And then in order to find the y values, we will substitute our x values into just one of the equations. One is sufficient to figure this out. So let's look at a couple examples. So here we've got example 1. It says solve this system algebraically. So these are both already in the form y equals, so that's good. That's a step that we don't have to do. So what we're going to do is, since they're both equal to y, I can take this 3x plus 6 and I can move it up here and replace the y so that I get this equation. 3x plus 6 equals x squared minus 2x plus 12. And now all I've really done is make myself a new quadratic equation to solve. So I'm going to solve that. I always like to start by trying to factor at least. So I'm going to get everything on one side. So I'm going to subtract 3x and subtract 6. So I get 0 equals x squared minus 5x plus 6. So I'm going to try and factor this thing. 1 times 6 is 6. The bottom I've got negative 5. Trying to find two numbers that multiply to 6 and add to 5, which in this case are negative 3 and negative 2. So if I go to factor this thing, I've got x squared minus 3x minus 2x plus 6. Use grouping here. The GCF of the first two is x. GCF of the last two is negative 2. Factor that out, and I get x times x minus 3 and negative 2 times x minus 3. Rearrange these, and I get x minus 3 and x minus 2. That all equals 0. Now, at this point, I know what my solutions to this quadratic equation are going to be. Right? This one's going to give me an answer of 3, and this one's going to get me an answer of 2. Now, I'm only halfway done with the problem, right? I've got half of each solution. I've got 2, and I've got 3. But now I got to find my y values. So to find my y values, all I need to do is take my x's and plug them into one of these equations. It doesn't matter which one, you'll get the same answers either way. So I always plug them into the linear equation because in my mind, that's just easier. So I'm going to say y equals 3. I'm going to start with 3 over here. 3 times 3 plus 6. That's 9 plus 6. That's 15. So one of my solutions is at the point 3, 15. Do the same thing with 2. So 3 times 2 plus 6. That's 6 plus 6. That's y equals 12. So those are my two solutions, 212 and 315. If I think of what my equation would look like, I've got this quadratic, and I've got this linear equation, and I'm just very roughly sketching these. And this point right here would be 212, And this point right here would be 315. All right, let's take a look at another example. So in this case, this top equation is not solved for y. So I'm going to have to do that first. Got 6x plus 2y equals -4. Trying to get that y by itself, so I'm going to subtract 6x on both sides. And then divide by 2 everywhere. Get y equals -3x minus 2. Okay, so now I'm going to do the same thing I did in that last equation. And I'm going to do -3x minus 2 equals 2x squared minus 5x plus 4. Okay, once I got my y by itself, I set my two equations equal to each other. Solve this quadratic, so I'm going to add 3x and add 2 on both sides, so that I've got 0 equals 2x squared minus 2x plus 6. Okay, so need to solve this. I'm going to try factoring. 2 times 6 is 12. -2 goes on the bottom. My top is positive and my bottom is negative. That means I need two negative numbers. I somehow have to get them to add to -2 while also multiplying to -12. It's not going to work. This can't be factored. So that means I've got to use a different method. I always default to quadratic formula. So if you don't remember, quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to plug my numbers into this formula. So I've got -2 plus or minus the square root -2 squared minus 4 times 2 times 6. That's all over 2 times 2. So if I start to work this out, I'm going to have -2 is 2 plus or minus the square root. -2 squared is 4. -4 times +2 times 6. 4 times 2 is 8 times 6 is minus 48. That's all over 2 times 2, which is 4. Subtract inside here, I've got 2 plus or minus the square root of -44 over 4. Okay, so I've got a negative square root here. So that tells me instantly that my answer is that there is no real solution. Okay, negative square roots always tell me no real solution. If I was to sketch this graph, this is just going to be like a very rough sketch. It would look something like this. Here's my quadratic equation. And here's my linear equation. They just don't cross. And that's all there is to it. So there is no real solution to this. So that's how you solve a linear quadratic system algebraically. You get them both into y equals, you set them equal to each other, solve for x, and take your answer for x and plug it back into one of the equations to find y. Just like always, I will leave you with a try it problem.